Let's talk about cosine law, specifically the missing angles case. So that's using cosine law to find a missing angle on a triangle. Okay, so just like any other trigonometry question, we first have to know what triangle we're dealing with. Okay, so as a reminder, a triangle is generally labeled by its angles A, B, and C, and this can be any sequence of three letters, A, B, C, X, Y, Z. I just tend to use A, B, C, but if it says different letters, you can use the same technique. Okay, but along with those angles, we have their pairs. So looking across from an angle to the side opposite from it, we find its pair. In this case, big A pairs with little a. Big B pairs with little b. Big C with little c. See, as we can go across to the line, you get the lowercase version of the letter to label the side. Okay, this is important so that we know where the sides are coming from, where the angles are coming from, and which side or angle we're talking about when we write out the equation. Okay, now cosine law is a little bit unique in that it has multiple different equations that we can use, but really we just sub out a different angle and a different side, and it's the same form. So to see what I mean here, the formula that we use for cosine law for finding the, I'll do that in black actually, for finding the angle A is the cosine of angle A equals b squared plus c squared minus a squared all over 2bc. Okay, so notice that the angle and its pair are here, but the pair is the one that's minus. The pair is the one that is subtracted and is not on the bottom. Okay, the other two forms that we can use here are the cosine of big B, so this is for the angle B, equals a squared plus c squared minus b squared all over 2ac. And again, see that this angle's pair is in the subtraction, and it is not present on the bottom. Okay, so you can start to see this pattern so that if I go to cosine of big C, we should know that this is going to be a squared plus b squared minus c's pair, c squared, all over 2ab. Okay, so you don't really need to memorize all of these, you just need to know how the form works. You get the cosine of the angle you want, then the sum of the squares of the two sides that are not paired with that angle, subtract the square of the side that is paired with that angle, and then divide by 2, and then the two sides that are not paired. Okay, which is all well and good, but how do we use it? Well, we have 5 steps to follow, and they're very similar to the steps that we followed in the past. So I'll just write those out here. Just going to give myself a little bit more room by making this a little bit smaller. We don't need it as a reference since this is a video, and if you need them, you can go back and pause. Okay, so the steps that we go through, and again, this is just to give us a reference for later, so we will go through these and how they work. So number 1 is, with every trig question, we label our triangle. Okay, again, that's just because we need to be able to look at the triangle and know immediately where each number came from. Okay, then the second, we choose a formula. Okay, so if you are using a formula sheet, you will probably want to write all 3 of these equations just because it makes it much simpler to quickly look and say, well, I need angle A, so well, there's A right away. You don't have to think about converting it. However, if you don't have a formula sheet, then this is more about figuring out, which angle do you have, which side is going to be subtracting, that sort of thing. Okay, once you've chosen a formula, we plug in our values, right? So the values from the triangle. And then and again, this will make a lot more sense when we see it, but we calculate the right-hand side of the equation. Oops. Teachers make spelling errors too. I'll just call it formula. Formula is probably a better word for that. Okay, so what right-hand side, I mean this side, right? Since we will have all of that information, we'll take a look at that in a moment. Okay, then finally, when the right-hand side is calculated, we take the inverse cosine. On your calculators, it's often just cos minus 1, which is usually done through shift cos on the calculator. And that will find your angle, and then we'll usually round it to the nearest degree. Okay, so that's kind of how to use cosine law, and we'll go through an example, but we haven't talked about when to use cosine law. Okay, so I'll go over when to use cosine law for both the angles case and the sides case, since it's important to know them together. Okay, I'll also explain why there's a snake in the corner. Okay, so cosine law and sine law are used in different cases. If we're talking about cosine law, then in a previous video we talked about when a triangle is sassy, right? So that's when you're trying to find a side with cosine law, and you're looking for a side angle side pair. So in that, I do mean that it's a side, an angle, and a side whose values we know. In the case of the missing angles for cosine, we're looking for SSS. That's why we have our little sneak buddy here to remind us that we need to look for S. That probably didn't sound great on audio, but it's like a snake hissing. Okay, so that is a side, 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 or in other words, a triangle in which we know all three sides. If you're missing even one of them, cosine law won't work, not for the angles. Okay, unless you have some other way to solve for the side, like for example, if you had this and solved for the last side. All right, that would be possible, but if you have two sides, no angles, nothing we can do. Okay, if neither of these conditions are met, then it's sine law. Okay, but for our purposes, just to show you how this case works, we're going to make a case that looks like this so that we can solve it. Okay, so here's our proposed triangle here. So we are given this triangle labeled ABC. So this is triangle ABC, and we're asked to find the measure of angle B. So I'm just going to quickly label the angle we're looking for here, just so it's really obvious for us. So we're looking for that angle there. So step 1, we label our triangle. A matches with its pair, little a, B with its pair, little b, and C with its pair, little c. Okay, now we find our formula. We're looking for angle B, so we're going to use the formula that includes angle B on the left-hand side. In this case, that's cos of angle B equals a squared plus c squared minus b squared all over 2bc. Okay, now we have our formula. We plug in numbers. Okay, so if we plug in these numbers, we will get cos of big B. We're leaving the big B there because we don't know what it is yet, right? Big B, don't know, we'll leave it. But we do know a squared. Well, rather, we know that a is 20, so 20 squared. Remember to keep the square, don't lose that in the translation here. So 20 squared plus our c, which is 17 squared, minus our little b, which is 30. And we keep that square. Then we divide that by 2, and then our b, which is, whoops. See, this is what I mean about mistakes. 2bc, that doesn't make sense. It's not going to be 2bc, it'll be 2ac. There we go, my bad. Right, because this paired side to the angle should not be on the bottom. Right, so there's a quick check there. So again, teachers make mistakes too, y'all. It happens. Important that we fix it. So that is 2 times 20 times c, which was 17. Okay, so now that we've got all that together, all we need to do is calculate it. Okay, so again, what we write? The cosine of big B equals 20 squared, which is 400, plus 17 squared, which is 289, then minus 30 squared, which is 900. And that's over 2 times 20 times 17, so 2 times 20 times 17 in our calculators gives us 680. Okay, just a couple more steps here. Again, I like to do this in different steps because if you do it all together, you tend to get lost, or rather, I tend to get lost. Just doing it smaller steps like this just makes it a little bit simpler. So if we do 400 plus 289 minus 900 on our calculators, we end up with negative 211. And that's okay. Cosine can be negative. That's what happens when you have a obtuse angle here, when it's larger than 90 degrees. Okay, and then we have 680 on our denominator here. That's a good sign because we have a smaller numerator than our denominator, which we know cosine needs. Okay, and we do that math. So we take 211 divided by 680, and that'll give us negative 0.3103. Again, I'm rounding to that fourth decimal place there. Okay, so now we've got a number. All we need to do is take the inverse cosine. So remember, the inverse cosine is the reverse of cosine, so it undoes that cosine, those cancel. But then we do the same thing to both sides because math is always, always, always fair. Okay, so if we take the inverse cosine of negative 0.3103, remember the negative there, it will change your answer if you don't include it. So if we do that calculation, we will end up with angle B, equals 108 degrees. And again, I'm just rounding to that nearest whole degree. Okay, so that is the end of that question. We've got our angle. So we went from just the sides of a triangle to the angle. So it turns out that if you have all the sides of the triangle, you can solve for each and every angle in that triangle, which is a super useful piece of math to know. Okay, so that's how to use cosine law, when to use cosine law, and how to use it to find a missing angle.